As developers in the year 2025, keeping our systems and applications secure is of the utmost importance. One of the most common ways that attackers can make our applications less secure is by causing a class of vulnerability called cross-site scripting attacks. Cross-site scripting attacks allow an attacker to inject malicious client-side scripts into our website and then have them run on our unsuspecting users' computers. It might just mine cryptocurrency, or it might try to steal their banking information. This has been such a serious problem for so long that the W3C has created the content security policy headers that can reduce, if not completely remove, the risk to our users. In this video, we're going to discuss why having the CSP header is a must if you're displaying any kind of dynamically generated content, how to add it to an existing website, and some important tips. Hello developers, and welcome to the PHP Architect channel. If this is your first time here, my name is Scott Keck-Warren, and on this channel we discuss a wide variety of topics related to the PHP ecosystem. Make sure you subscribe so you can get our videos as they're published. Now, I think that the easiest way to grok the content security policy is to think of it as a whitelist for the browser. Instead of trying and failing to stop every possible bug server-side, we can use the content security policy header to instruct the browser to only load specific scripts, styles, images, and other resources to reduce the attack surface of our site. Because even if an attacker can inject a script or an inline style, CSP will minimize the harm that they can do. You're going to do this by providing a header in your HTTP responses that will specify exactly what sources of external data are valid for your application. It can be sent either by your web server, which is more secure, or via your code, which is a little bit more flexible. I like the approach of setting it via your web server because it's harder for the attackers to compromise this setting, but being able to set it in your code makes it easier to support situations where third-party libraries don't play nice with your specific settings. I should note that content security policy is not a replacement for secure coding, but it's just another piece of a layered security approach. Unless you're on a greenfield application and have no users, I don't recommend just switching on the content security policy header and hoping for the best because something is going to stop working. Thankfully, when they built it, they decided that content security policy headers provide a way for us to gradually turn it on and get information back about what's going to fail and what won't. We're going to take a phased approach to turning on the content security policy headers. In phase 1, we're just going to start in report-only mode. In this mode, the browser will not block anything, but instead will send violation reports to a destination that you define. This helps you discover what in your site actually is being used, and then what will break when you turn on the policy. The HTTP header for this is the Content Security Policy Report Only header. So as an example, let's look at the following basic PHP file that we've named test.php with an example script tag that was injected by an attacker. But it also includes a JavaScript file that we actually want to have loaded. If you access this in a browser, you'll get the injected bad code, but also the good code. To start collecting data about what violations there are, we need a script that will store the responses to a log or some other system, so we can then investigate them further. To do this, at the root of your directory, create a file named cspviolationreports.php and enter the information on the screen. This is just going to take the data that's sent to the script in the post of the body and store it into a log file for us to examine later. Now we're going to go back to the top of our test PHP file and add the following at the very top of the file so that it gets included in the response. This is what's telling the browser that we want to enable content security policy in report-only mode, and then we want JavaScript to load using the same domain as the requested page, and then if there are any violations to this, to send a report to our script file that we created earlier. Now if we refresh the page, we'll see it's still running the injected code. However, when we check the log file, we'll see the following line. There's a lot here, but the important thing is that it's telling us that the blocked URL was an inline script. You can then investigate how to fix the issue. This information will also be logged to the browser console so you can see it as well. For example, in our testing, we might find that we have a page that includes some JavaScript from a content distribution network, and we need to allow that in our system. The browser will report back the following, which tells us that the URL isn't allowed per our current settings. To fix this, you can add the specific domain to the Content Security Policy Report Only header so it will be allowed, and you'll no longer receive the report. In general, it's a good idea to enable the reporting locally, do a bunch of testing to see what problems exist, and then either fix the generated HTML or make the rules more permissive before pushing to production. Because the browser will make one HTTP request per violation, and depending on your traffic, it can really add up. Now, I don't need to tell you that production monitoring can be complicated. There are tons of tools and techniques, but you just want to know that your app is up and your users are happy. When your customers encounter a problem, you need clear, actionable intelligence, not walls of charts and reams of logs. That's why they built Honeybadger, the monitoring tool you've always wanted. A tool that's there when you need it and gets out of your way when you don't. With Honeybadger, you'll know when critical errors occur and which customers are affected. Respond instantly when your systems go down, improve the health of your systems over time, and fix problems before your customers can even find them. Honeybadger is the application health monitoring tool built for you, the developer who cares about a quality product and happy customers. Start monitoring today at honeybadger.io. It's free to get started, and the setup takes less than 5 minutes. Once again, that's honeybadger.io. Now, moving on to phase 2, once you feel comfortable that you've gotten most of the items cleaned up, you can push it out to your users. Again, we're only reporting, so nothing should break. Depending on the level of traffic that your site gets, you might want to check back after an hour, a day, a week, and see what new items are reported back to your server, and then fix them so that those errors are no longer reported. I would just repeat this until no new reports are generated or you feel fine blocking the items that you're seeing. And then in phase 3, we're actually going to turn on the blocking. Now that you feel comfortable that you're not going to break your site for any of your users, you can enable the policy using the content security policy header, and then just copy and paste the settings that you've been testing. And this will prevent the inline code from running when we finally refresh our page. Now, the best option for your content security policy configuration is to not allow inline code or styles, but you'll occasionally need to do so. For example, we have the following page that only allows external scripts, but we do have some code that we need to run dynamically. Now, because we've set up our content security policy, this inline code isn't going to run. To get around this, we can build what's called a nonce, and then specify it as part of our content security policy header. And then we can include it as part of our script tag like so. This will tell the browser that we vouch for this section of the code, and it can actually run it. I don't recommend this as it does open a new attack vector because someone might be able to get PHP code injected into your page, which will bypass the checks we've added. Now, this video just starts to scratch the surface of using content security policy headers. So far, we've only talked about how to control how scripts load, but CSP allows us to control CSS, images, external connections, fonts, applets, audio and video files, and iframes, and more. There's also a default source option, which controls almost every option, which is generally the best way that you can use it. There are also a ton of options for defining what's allowed and what isn't, so don't feel limited to what I've shown you here, even though I do recommend that you just allow self and maybe 1 or 2 CDNs. As a brief recap, content security policy headers allow you to limit what content is loaded from your HTML. There are tons of options for it, and please at least set it for your scripts. I hope you enjoyed our video. If so, make sure you comment, share, and like, as it does help others find us. Maybe share this with a coworker so they can be introduced to content security policy headers as well. Other topics that you'd like to see us cover, let us know in the comments section below, or send me a message on any of my social media accounts. I love to hear how I can help you, and it always brightens my day when I hear from a fan. This is Scott Keckwarn for the PHP Architect channel signing off, and reminding you to keep watching, keep coding, and keep reading.